Welcome to another edition of ALN Thursday at 3. Today we are talking with Kimon Onuma and Rick Justice. Kimon is the president of Onuma Inc. and Rick is the executive director of Linux Foundation's Coalition for Smarter Buildings and the Asset Leadership Network through our patron member Onuma Inc. is taking a leadership role with the activities of the Linux Foundation. And we're doing this because we have a real life example of how to make asset leadership complexity clearly beneficial. And we'll be exploring how the PAE story is doing that specifically through an article that Kimon Onuma has created for the Automated Buildings online publication. And by walking through this very clear, simple article that has links to videos, we're recommending that leaders or the people who influence leaders understand this approach. We need to have more of these demonstrations in real life projects to move the ball forward, and everything is in place for that to happen. And that's what the article spells out. But we'll get to that shortly. First, we'd like to thank our patron members, Mantech, Onuma, ABS Quality Evaluations, and all of our organizational members, including Skycentrics, which is part of this article, and the activities being done through the Coalition for Smarter Buildings. So without any further delays, let's bring on Kimon Onuma and Rick Justice. Hello, gentlemen.
Hello.
The Asset Leadership Network has been doing a very good job of highlighting the work that was done for and at the ASHRAE AHR conference / convention. And then this article that Kimon provided for Automated Buildings really drives home what is being accomplished and makes it clear what the different parts of the process are so that others will want to follow. So, Rick, as executive director of the Coalition for Smarter Buildings, I think you're pretty happy to see this type of article and the clear way, because nothing about what we're doing is simple. Let's just get that straight, okay? But it's now possible to be integrated in ways that were not possible before. And that's what the Coalition for Smarter Buildings has been striving for all along, right, Rick?
Yeah, I think that's pretty well said. And I think the time frame of the AHR conference and then the presentations that I think are going to be highlighted here are was very timely in that the work of the different working groups and the specific examples and the different leaders that were able to present their pieces. The timing was kind of worked out great. And the conference itself, being in Las Vegas, was very well attended. The messages that were being presented, I think, were very well received. And now the next steps are going to be what's the most exciting. So getting the word out is again very timely. But the some folks have said that we've been keeping all this work a secret, and that's just not true. And sometimes it looks like we've been keeping it a secret, but what we're really trying to do is get to a point where it looked more obvious. The word simple you used, nothing simple about what we're doing, but it kind of reminds me of what's the analogy where they talk about the duck, floating on the pond. It looks like it's all super calm. Um, that's how we want it to look. We want it to look, matter of fact and obvious and inevitable that these things are all coming together. Meanwhile, there's a lot of paddling going on under the surface to get
Very well said. and it's coalesced, right? So the coalition, that's the important word in this, is these efforts are, in another simple way of putting it is acknowledging that one company coming to an asset owner and saying, we're going to do everything for you is no longer a viable approach. There are too many innovations that are happening every day, and organizations need to be agile to be able to use the most and best approach. And the coalition of this allows that to happen. We're showing this. And it's leadership that needs to say we need to shift from walled gardens to an agile approach. Kimon, you've been after that for decades.
Yeah, yeah, it's pretty exciting to see it come together, and it's multiple things kind of happening at the same time. Is there's the need's been there for decades, like we all know. We keep talking about silos and open standards, open source, and then the complexity just is increasing dramatically because all these systems now want to talk to each other, especially driven from AI. But even before AI came along, we didn't have good access to intelligence and information. So AI just is a driver that says, hey, it's time to open some of these connections up so we can have these conversations. And the complexity really is, if you break it down into pieces, you can have a simple piece that relates specifically to you. And that's the beauty of this technology. It allows you to ask the question from your perspective, the prompt, if you think of a prompt box, and everything else in the background is there as long as it's connected and relatable. And that's what the C4SB is doing, and what we've been doing with the Linux Foundation is learning from those methods to apply it to the building industry, finally.
Finally, exactly. So nobody's got to be scared. This approach has worked for the Linux Foundation in many industries, and we are the ones who are honored to be bringing the building industry to this open source collaborative approach. So, Kimon, why don't you go ahead and share your screen and let's walk people through.
Okay. All right. So maybe we start from PAE because that was a big catalyst as far as sharing information. As an architect, I've seen this over the years that projects, architectural and engineering projects or buildings, and the process of how you get to engineer and design a building is pretty much in a black box. It's not really shared. You kind of see the end result. But PAE essentially said, hey, we have a building that we occupy for our own office in Portland, and we're going to learn from this building because the systems are not talking to each other. Let's open source the process and post the results and share it with the world, which is a huge kind of a decision to come from an engineering company or an AEC company, essentially, to share that information. And I think that's probably one of the most significant pieces, apart from all the technology. It's a cultural shift, the willingness to share, which is a leadership and a governance
Yes,
shift too, right?
yes.
So that's kind of the foundation. And the sharing is not even just all about technology. It's about knowledge and methods of what you do as an engineer or an architect or an owner, which is essentially the story of what you're doing. And I describe it like a story. It's really a story thing. How do you tell your story and relate it to the rest of the process to create value so it's not a bunch of disconnected messages or information?
So from the asset management perspective, that is your organizational objective as um, stated in your strategic asset management plan. While there wasn't a formal strategic asset management plan, the owner said, we want our assets to share their information more readily with us so we can make informed decisions.
Right, exactly. And you can start simple, and the main thing is just to start. I mean, that's another big message that we've been seeing in the industry for quite a while now, but especially in the last few months or 6 months with AI pushing on a lot of this. There's no more time to talk about it. There's been a lot of talking going on for decades about how do we make the perfect standard, or how do we make the perfect connection? Now is the time to actually create those connections. And with AI, for example, the development of applications is heading towards being free almost. You can create an app if you have the right platform to build on and have the right connectivity to the other systems. And that's what this PA story is really all about as well too. So should I just kind of scroll through this and
Please.
talk through it?
Yes.
Okay, so this is the one art. There's going to be 2 articles I'll point to. There's quite a few, but there's 2 that we'll show today. This is about the bridging the PA living building. We call it From Models to Meaning, and we had 4 presenters at the C4SB booth, and we also presented at the ASHRAE conference as well. With Cyril was there as well too, so it was a different mixture, but this was at the booth itself, talking about the C4SB process. So it was Tristan from Skycentrics, Stephen Lothrop from PAE, and Paris Dudashai from NIST, and myself.
Yeah, but you mentioned Cyril Verlee, who is president of ALN member organization, CDV Systems, and he's got 26 Degree Software. And also Tristan de Frondeville is president of ALN members, Skycentrics.
Yeah, that's right. So the theme was models to meaning, and the meaning is kind of interesting because you can build models, physical models, but what does it really mean? I mean, what's the engineering aspect of this bridge, for example? You know, what holds this bridge up? There's engineering rules that relate to the structure, that relate to the load, all that kind of stuff that goes into building a bridge or a building. And in this case, the PAE living building is an amazing building. It's zero net energy, zero water. They have their basement is the size of an Olympic swimming pool. They're collecting all the water, the rainwater and everything, and using it for the building. And there's no waste going back out to the systems. PVs on the roof, 20 EUI, amazing systems, almost 10 different systems in the building, and none of them were talking to each other. The technology was basically delivered in documents and digital and even paper documents maybe, but that's kind of what happens after construction. The knowledge, the meaning of why did we build this like this gets lost, and then it becomes very difficult to extract.
Now, they did engineer it
Mhm.
with the best at the time approaches,
Mhm.
but the best at the time approaches weren't talking to each other in an
That's right.
effective manner. If they had put a lot of effort into it, they could have, and then they wouldn't be able to teach anybody else how to do it. It would have been a one-off, and they're interested in developing a repeatable process. So it was perfect candidate for this.
Exactly. And this is Stephen presenting. So each of these, there's short videos of each of these sections, and Stephen kind of walks through the introduction of the PAE building, describing all the systems. So amazing systems, but proprietary connections, which means you couldn't see the PV energy from the roof next to the utility meters, next to the battery levels, next to the lights and the sensors in the building, all different systems not talking to each other. And this is the engineer that designed the building in the building not being able to see their own data. So they knew that was a problem. If that's happening in their own building, it's happening industry-wide. So that was the objective from last year. Let's take this and decompose it, essentially get the knowledge that is baked into single line diagrams. Imagine a single line engineering diagram that says this panel is connected to this light. You break it apart into what's called a knowledge graph using ASHRAE 223P standards. And this is where it kind of gets kind of technical. We don't all have to understand the technical aspects of it. You just need to know, okay, if I'm an engineer and I'm creating a rule about this piece of equipment, if you capture it in a knowledge graph, then others can use it to manage and maintain the building, for example. But if it's baked into PDFs or into documents that are in a binder, then you have to go look for that information and you might not even ever find it. So we took all that with the C4SB, and many different groups were involved, including PAE, Pacific Northwest National Lab, NIST, Skycentrics, and others. And we took their BIM, their building information model, and put it in what we're calling a cloud BIM format. And everything, it's called a cloud native, cloud first approach, where if you have things in the cloud, whether they're local or actually in the cloud, then they can talk with a common language and connect the sensor data to the floor plan. So the end result is we took all the great data that was kind of a spaghetti code format and structured it. Once you structure it, you get a living building that has knowledge and meaning that can be queried by humans and machines to make decisions about the day-to-day operations of the building.
Okay, you said something that I think is one of those complexity to clarity statements. By having the information that's cloud native, it can communicate with each other because it's already in a web format.
Right.
You want to expound on that a little bit? Because isn't that the heart of what we're saying here and what the Linux Foundation has helped many other industries do?
Mhm. Yeah, exactly. So if it's in a machine readable format, in other words, when you go on the internet and you type a web address, that's kind of a standard in the background that says if you type in HTTPS, you get to this site. If you don't have that protocol, then you have to go to that system and say, hey, we want to get a document from your server. It didn't used to happen like that. So these standards allow the data to flow to other systems. And literally, if you have an open connection, it could take seconds or minutes to actually create the connection versus, I mean, 12 months, 18 months, or never for a lot of owners that say, well, we can't get to the energy data in our building because it's in a proprietary format. And unfortunately, over the years, different vendors and systems and even the AEC industry, they intentionally make the data difficult to get to because then they can sell it to you in a format that is their own format and you're kind of stuck to their format. So it's a business strategy versus a technology issue. The technology has been there for years to allow these open connections. So when we dial in our mobile devices an area code, it knows to go to that area code and call up the other phone. And all the technology in the background is just invisible. You don't need to worry about it. You just punch in the number or ask your phone to call that number, for example. So that's what's happening here. Essentially, systems can say, hey, I want to see the current level of the battery in the building. They're collecting energy from the PVs on the roof. What is the percentage of the battery in the building? Because that's critical for day-to-day operations, and it can answer to that. And yeah, so then there's ASHRAE 223P, which was Paris 2, which is NIST, and it's a standard for these technologies to talk to each other. And that's the critical part that C4SB is focusing on. How do we get a common way to describe if you have a mechanical system, how does that mechanical system connect to the energy use, to other systems, to the airflow, whatever. All that stuff is structured in a format that's query. That's what she's showing on the screen here. How do you query it to ask it that question? And then once you have that, you can have either humans or machines actually querying and asking that question. What's the energy level in the building? You do have to have all this complexity in the background, but it goes away to the end user. You don't have to know all the details.
And
Just that
that's what I like about this article, Kimon, is you present this in digestible amounts. There's not a lot of text here. If you're interested, you can watch the video. You don't have to know everything that Paras 2 knows, but it's important to understand it works so you can present it to your leaders to say, we need to be agile. We can't be beholden to walled garden software approaches.
Yeah, it's basically a common language. It's a semantics and ontology. We're saying if we use a common language, each user calls things in a different way, right? So some people might call it a room in the building. Some other systems might call it a space. Some other people might call it 101, but it all is about that room 101. Once we have that agreement, then you can say, what is the temperature in space 101 or room 101, or where is the air handling unit that supports that room? So it's the context of the building, which is essentially the map. Once you have a location, then you can have a conversation of what's happening in this location with the energy in this building that's using for that light in the building or the piece of equipment in the building. And then Skycentrics was what enabled the connection through an open standard in the PA building. The Skycentric Skybox was installed as a router, basically a little computer a very low cost computer that connected through cellular, through the network, that saw the data from the building that allowed us to create these charts and graphs and open up the dashboards that were locked into 10 different systems to be able to connect to BIM and digital twins and all these different systems. That's the other critical thing we demonstrated quite a bit in the C4SB PAE project. The industry has become used to thinking in terms of what single application should we buy to do this thing. That's not scalable because the world today is we don't use our phones with one app. We just use an app. If you don't like that app, you throw it away and you get another app. And that's what we're talking about here is we want to have freedom to access anything, including other types of uses. So for example, agentic AI, for example, we want agents to be able to talk to the cloud BIM, to be able to talk to the IBB that has the open building stack from Skycentrics that shows us the energy that's coming from the BACnet device. All that stuff starts getting wired together. So you don't have to build it from scratch and you don't have to be locked in any one single application. So that's this article number, the first one, and then the second one. Should I move the second one now?
Sure.
Okay. Okay. So now we're getting to this second article. It's called the Coalition in Motion. This is about the Coalition for Smarter Buildings, C4SB, and how we built the bridges and said at machine speed. Once you have those connections, you don't have to rebuild them each time. It's like you have an outlet with a plug and say, I want to get energy from this outlet. You don't have to make a calculation about how do I get energy from this outlet or how to get information in that system. You start plugging things together. And I put this in here. I've never seen a convergence like this. We've seen over the last few decades conversation and discussions and theory and whatever and the perfection of standards and talk. The Linux Foundation likes to call themselves a doocracy. You actually do things, you build things, and you start getting collaboration by doing things together rather than talking in theory. Theory is important, but unless you can put it into practice, it means nothing. And that's what we did here. So we talked about it. So this is a snapshot of the other things that the Linux Foundation does. There's a lot of other things. The coalition is here for the built environment. So if you look across these things, there's a lot of other like financial system, security system, networking, all these other technologies that can support buildings as well. Energy, for example.
And can use the information from buildings to do their processes better.
Yeah. And the way I look at it is buildings are kind of the map of the building. Imagine before we had Google Maps and maps in our mobile devices, we had paper documents, right? As soon as you have a map, you can say, I am in this location and I'm trying to find my way from point A to point B. If a building doesn't have a map, you just have a bunch of data that looks great, but might be meaningless unless you can put it into context. So the semantics and ontology, the name of that room in that building, on that floor, with that piece of equipment in Portland, all of a sudden, boom, you have a story there that you're talking about that particular building in Portland just versus just a bunch of random data. So we talked about rewiring the built environment and why this moment is different. This is different because last year we started at AHR and we met with PAE and we created this objective of let's use the PAE building as the exemplar of how these systems can talk to each other. Once we could do it for one building, the goal is to be able to scale it to any building with the same formula. BACnet was there's a presentation from Jim Lee about BACnet and the history of BACnet. And one interesting point he made is it used to take years or decades to get different versions of BACnet out. It's an open protocol to be able to have communication going in the building, but now it's shrinking down. The development of the implementation and launching of standards, especially with AI, is shrinking way down, and it makes it easier to and faster to develop solutions on. So it's more of a technical part of that.
I believe it was Jim who pointed out that Moore's law showed that every 18 months computing capabilities doubled. And he says AI is increasing capabilities every year by 10 times.
10 times, yes. Yeah.
So that means in 2 years, that's 100 times. And human behavior is going to have a hard time keeping up with that, which is why I like the clear approach that you have of showing this information.
Mhm. Yeah, we talked about Paris doing the meanings of the ASHRAE 223P, which is a standard for that. And then there's also the digital building profiles from David Holmberg from NIST, describe what C4SB is doing along with other standards, building standards. It's not one or the other. We're saying anything that exists out there as a standard, open standard or open source or anything else, we can use that instead of reinventing the wheel. That's another shift here. We're not claiming to be creating something new other than the process of connecting all these things together through building digital building profiles. Essentially are the process models and the definition of what do we need to do in the building. What is the use case? What is the story? And then you run with that. Cloud BIM, we talked about it. Once you get systems in the cloud, you can start wiring them together and doing things like the charting and everything that we talked about with the PAE building. And then the open building stack from Skycentrics and what they were doing for the PAE building about connecting the actual sensors and BAS building automation systems and management systems in the building. And Lawnmark it was the Lawnmark booth, and Lawnmark is part of C4SB. And Tracy talked through that. And then one interesting thing that he talked about is 70% of buildings are not these large buildings. They're smaller scale buildings, or 70% of the inventory out there of existing buildings are smaller buildings. So it needs to scale from small buildings all the way to large buildings to the city. And if we're going to get to smart buildings and smart cities, we need to think like that. And Pete Scanlon talked about TXO, or the total cost of everything, as it's called at C4SB. How do you start making financial decisions, which goes back into governance and leadership? How do you make decisions on how much money is being spent to design, construct, operate, and into the life cycle of the building? So there's a tool that's being developed as part of C4SB to input simple questions, and then it gives you some range of, well, here's what the cost would be for that. And last but not least, you can talk through this.
Yes, I was able to talk about how there's an asset leadership standards committee in the Coalition for Smarter Buildings. And what we're doing is establishing repeatable processes that top executives can follow in order to gain the benefits of bringing this all together like PAE is doing. And we're looking for other asset owners who are interested in gaining these benefits and publicly sharing them so that we can rapidly deploy these best practices. And we need to shout out to automatedbuildings.com, which I put that link in the chat, but the chat was only going to the panelists. So let me put that in there. Click on that, and it'll go right to it. And the top articles are from Kimon. We need to shout out to them because they have an excellent format for authors to publish their own articles. And in this format that Kimon has used, that has short amount of text with links to more detailed videos, it's an excellent learning experience. So we really applaud Automated Buildings, who has Carrie Lee Sinclair in it, and she connected us to the Australian Embassy. We talked with them earlier this morning to see if they will host an event on April 28th in the Australian Embassy in Washington, D.C. And it looks good. Don't have any confirmation yet, but excellent start to kicking off a week of events in Washington at the Australian Embassy. Thank you very much, Carrie Lee Sinclair, and Automated Buildings in general. So, Kimon, thank you for taking advantage of the Automated Buildings open format for publishing articles. What you have done makes clear sense of the complexity of what Rick started us off by saying. The duck above water is calm, and underwater the legs are paddling like mad. And I haven't seen any presentation of complex technology that's as clear as what you've done. So thank you for that service to the industry. And thank you for joining us today on ALN Thursday at 3. And do you have any future programs you want to promote?
Next Friday, there's the Microgrid Consortium where PAE and I will be presenting and talking to them about from a microgrid perspective. This is interesting happening, and I put a link. It's free to join. It's next Friday.
It's a web program.
It's a web program, yeah, from
Do you
Seattle.
know the time? Is that there? Yeah, it's right there. Why don't you go ahead and say that?
Yeah, 7 o'clock on the 27th Pacific
7
AM.
a.m. Pacific time.
Pacific, yeah.
Okay, so that's 10 a.m. Eastern for all of our Washington, D.C. and East Coast attendees. So thank you so much, Kimon, and thank you to the attendees. We appreciate that, and we'll see you all again next week on ALN Thursday at 3.
Thank you.
Bye for now.